Hello Laravel friends, today is special because we're going to talk about Laravel Service Container, which is a huge topic and one of my favorite ones too. I really love this part of the framework, which Laravel itself uses a lot under the hood. But yeah, also this topic can become quite hard and difficult to understand, especially at the beginning and especially with all those fancy terms. So I want to change that today and give you a proper introduction to this topic, which is less about what the container is and how it works, and more about why we need it, why you need it, which I believe is more important and helps you better to understand it. All right, are you ready? I am, so yeah, let's go, let's do this. So in this application, we have an image generator, which needs to generate an image, but currently we're just returning a string, which is not so good. So let's use AI for this. So we're going to start by not thinking about the container at all. We're not thinking about dependency injection at all. We're just doing what it takes to make our code work. So here we need to use an AI service. So let's create a new one. We have one here, AI service, and then instead of just returning a string, we are using our service, generate image, and we are providing the prompt. All right, in the end, in our example, this will still return a string, but it doesn't matter. So what do we have now? We have created now here a new instance directly inside this method. Does this look better already? It's pretty simple to understand what's going on here in this class, in this method. We don't have much arguments for this dependency. It doesn't look that harmful. So let's just leave it as it is for now. Next to our image generator, we also have a blog post generator. Very similar. We also need an AI service here, so let's do this as well. AI service, new AI service, very easy to spin up here, a new service, and then we use it to generate text. Now in this case, again, we're using the prompt, which we receive here, and voila, pretty much the same as before. The only little disadvantage which we currently have is that we have a little bit of duplicated code here, but it's not really that much, so I don't really see this as a big issue yet. Okay, what's the next thing here? Let's take a look at the AI service. And let's imagine, currently, as you can see, we're just returning some strings here, which is easier for this example, but maybe you want to, probably for sure you want to call a real AI service in order to get what we need. So we would need a client. So let's create a new client here. We're using a Gusler client here. All right, maybe we would copy this here because we need this in this other method as well. Okay, maybe it's a good idea to introduce a constructor, and let's just create a new property which is called client, and here we create our new Gusler client, and let's also create here this new property. All right, so this means we could get rid of this here, and here we would make our HTTP call. Make HTTP call to AI. Okay, and we probably would do this here as well. Okay, but still we are not using dependency injection. We're just creating this in the constructor so that we have a property and that we can use this. Okay, still, if we take only a look at this class, it's pretty simple to understand what's going on here. So is this really an issue that we create this new instance here inside the constructor? And similar to what we did here, just inside this method. Yeah, but you can see we're spinning up new instances of our dependencies here and there, and it becomes a little bit already obvious that this could be a little bit messy. First, we have some duplicated code like we have here for our AI service, but also it gets a little bit more difficult to see what's going on inside a class. Here we have this dependency at least created inside the constructor, so we immediately see that we have this dependency. But if we have those new instances just inside methods in your class, probably you wouldn't see what's really going on in your classes, and you probably would use more dependencies that you maybe want to. That's one side of the issue. The other issue is that since we are spinning up the dependencies inside here or inside the constructor, we have no control from the outside anymore. So if we want to use a different dependency, a different client, for example, we have to go directly to this class and change this. If we want to use a different AI service, we have to go directly to this class and change this. And now this is where it becomes a little bit blurry and messy. And with bigger application, you will run into issues maintaining this application because now all those different classes and methods have a lot of power and are in control of doing way more than they should be. And that's where dependency injection comes in handy. So let's try this out for our AI service first. So we need here a client. So let's ask for a client. And let's call it client as well. We don't need the property up here anymore. We do this in the constructor. We don't need this anymore. And now we can have access to this client inside all of our methods here, but now we're using dependency injection. Again, not that big of a change here, besides that now this private client comes from the outside, which means we have a little bit more control, and this class has a little bit less control, which is a good thing. So let's take a look at our image generator. So this new AI service, which we spin up here, needs a new client as well. All right. So now this looks like this. Okay, but now we have the same issue here. Now this image generator has a lot of control about what client we need, what AI service we need, but actually it should be more about generating an image. So that's the main purpose of this class. So let's try the same as before. Let's use constructor injection here to solve this issue. So this means we are creating here now a new private AI service. Call it AI service. And now instead of this here, we're just using this directly, AI service. And now we don't care anymore how we get an AI service, which AI service this is, which client this AI service uses. We don't care about this. We just get it here through the constructor and we can easily use this. So similar to AI service, we have cleaned up this class. We have changed the control flow a little bit because we have less control here. But again, this class is being used somewhere else. So again, we are pushing just the problem a little bit more up. All right, so the image generator is something that we want to use here. So in order to get an image generator, what do we have to do? Let's start simple again. We are creating just one. And now this image generator, what does this need? This needs a new AI service. All right, and the new AI service needs a new client. So all of the things that we've done before in the classes below, we're doing now right here. And the image we get now through the image generator, generate, and let's say a beautiful sunset. All right, we also can test if this is working. Inside my browser here, I have this little UI where we can see what we get back. We don't get the real image, sorry, but I kept this out for this example. But we get the text, which we have provided, a beautiful sunset. Okay, so we have the same issue as before. Now this controller has a lot of control and a lot of power here and needs to decide how to create this AI service, and now how to create the client as well, which now it really looks messy here, and this is something that we don't want. So what can we do? Can we use constructor injection as well? Let's give it a try. So we're creating a new constructor. We say we're expecting here a new image generator. All right, let's get rid of this here. Now directly use this image generator. Does this still work? And it does. Let's try it out by creating a beautiful dog. Yeah, so we still get back what we expect here. Okay, but why is this even working? Because we don't create the controller instance ourselves. We can provide the image generator to the controller. So this means Laravel does this now for us. And this is a very powerful concept called auto-resolving. What's happening here is that Laravel sees, okay, I'm creating the controller. The controller has a constructor. Let's take a look. It needs an image generator. What is this? This is a class. Laravel can do this through reflection. Checks that this is a class. Okay, let's take a look at the class. More dependencies. Let's take a look. We need an AI service. This is a class again. Yeah, okay, I can do this as well. Let's create a new class. But what does this class need? This also has a client here as a dependency. What's the client? The class, I can create a client. This client has no arguments. Okay, good. I'm creating now this image generator for you because I know how to do this. And this auto-resolving is a very powerful concept here which helps you a lot with dealing with dependencies, because Laravel and the service container can help you to create your dependencies on the fly, especially if they are not that customized. But of course, auto-resolving has its limits. We'll take a look. But another example that I want to show you, we can also use method injection here, which is very similar. So we can just say that we want the image generator here. Again, we're not passing it ourselves. Now we can just directly call image generator. Our app will still work, and now this is being injected directly into a method, which again is super cool because now we can get rid of the constructor. Again, it gets a little bit more messy if we have more methods, what dependencies our class has. But if we only have this one method, it's still it's pretty obvious that we have this one dependency, which is an image generator. And you've done very similar things already. Example for the request, which is this request here, which we also get inside our controller if we want to, and we often need to use this. And I'm pretty sure you have used this already. So let's dump this out, and you can see we get a request object back, which we do. So I'm pretty sure this is something that you have already used. And again, auto-resolving, super powerful feature of Laravel, but as I mentioned, it has its limits. Let's take a look at the generator and our AI service again. Let's imagine that next to the client, we also need an API key for our AI service because we want to call a specific AI service. So what do you think happens now? Let's try this out together, and we'll see an issue here, an server error because we have an unresolvable dependencies, because Laravel now sees, okay, we have the client as an argument, I can create a new instance, but now we have a string, and I have no idea what this string is or should be, because this could be literally anything. And that's when we need to tell the service container a little bit more explicitly what we need for this AI service. And this is where service provider come into the place for us to rescue. I have already here my app service provider, which comes with every Laravel application, but you could also create a new service provider for these things. So what can we do? Here we can tell the service container exactly what we want to return if someone asks for our AI service. And we do this by using the app instance, which is also the container, and we want to bind something to the container. So this means we're giving the container some specific instructions. So in our case, when someone asks for the AI service, which is just the string here, so the first argument here is a key, then we can define what we want to return. And in our case, we want to return, we already have it in the controller. Oh, I got rid of it already. Okay, let's return this, create this up again ourselves. We want to create a new AI service with a new client and an API key. And now this API key we now get from our config file. And it is called key services AI key. Yes, here it is. All right, let's try this now again. And voila, our application is working again because now Laravel knows what it does, because we have told Laravel and the service container exactly what it should do when someone asks for our AI service through the container. And this is now super cool because now we have here this one place inside the service provider that defines how we create an AI service. And whenever we need someone in this class, in another class, somewhere else, we just have to ask the container and it will give it to you. And you don't have to create all those new instances or maybe use API keys somewhere else. So there's just this one place here now, which makes your code very good to manage. And that's pretty cool, right? So I really hope you already see a little bit how excited I am about the service container. And I really hope you get too, because there is so much going on, which is just so cool. There's another example that I want to show you. So our AI service, let's rename this to OpenAI Service. All right, and then we're going to copy this class and let's call the second one Cloud AI Service, which is another AI service provider. What do we want to do here is we will have now two services, OpenAI and Cloud AI Service. And inside our service provider, currently we define that we want to use the OpenAI service, but we could also change this to use the cloud service. And now this service is used instead. Still, we have this one place where we're going to change which service we want to use. But the issue is here a little bit now that inside our image generator here, we are specifically asking for one service. And if we want to use a different one, we have to change this here as well, which if you have multiple classes where you do this, is not so good anymore and can become a little bit of an issue. And that's where interfaces can help you a lot. Let's create a new interface for our AI services. Let's do this through PHP Storm. I have already the method selected that I want to use, and let's just call this AI Service Interface. Okay, let's implement this now also for our OpenAI service. Here we go. And now inside our image generator, we're now saying that we want to get an AI service interface instance. Of course, we can't get an instance of an interface, but I hope you get the point. We don't care which service it is. If it's OpenAI, if it's Cloud AI, this should be defined somewhere else. We just want to make sure that we get an AI service that we can use. So the issue now is if we try this, we will run into another error because here again, we can't create an instance of an interface. Laravel can do this and we can do this as well. So this is when we need to tell the service container again, whenever someone asks for our interface, then we return Cloud AI. Let's run this again. You can see this is working. So this means we are now defining here which service we want to use, and we don't have to define it in all the other classes because now we're saying just we want an AI interface, or we just want an AI service. We don't care which one it is. This is being defined somewhere else. And when we change this, which one we want to use, maybe you create another service that you want to use, there's now only this one place where you have to change this, and you don't have to change this directly here with your type hints, which is really, really cool because now this makes your code way more manageable than before. And I'm pretty sure you've seen in Laravel similar things already because when you're asking for a database, for cache, or a mail driver, you don't specifically ask for a specific one, you just ask for a general one, and somewhere inside your configuration and environment files, you have defined which one you want to use. So this is a concept that Laravel uses itself a lot. Okay, if we take a look at our routes here, we also have a blog post controller. So where we still have to do this as well. So we have here a blog post generator that we want to use. And now our text, which we get by using the generator, and a Laravel introduction is the blog post that we want to generate. And here we also change this to provide a text. And we provide the text here. Okay, then inside our example, let's go to another endpoint, which is blog post. And now we can see this output as well, a Laravel introduction. So this also works. Okay, but now we have a blog post generator and we have an image generator. And let's say that we have found out that Cloud API works better for images and OpenAI works better for text. So we want to use two different ones and not just use one that we define here. And now is something really cool that we can do here as well. So it works like that. So when our image generator, the class, needs an AI interface, an AI service, then we can define what we want to give. So we can create here a callable again, and let's copy this in here. So this means for the image generator, when it needs an AI service, we want to provide Claude. And let's do this also for the blog post generator. Then we want to provide OpenAI as a service. So this is contextual binding. For specific context, we want to provide the different dependency. All right, you can see this is still working. Let's check out inside our image generator. If I dump out our AI service, we should see, I think this should be Claude. And here we get now Claude AI service for the image generator. And for blog post one, let's try this here as well. Let's dump this out. Our AI service and call the blog post. Yeah, you can see now we have here OpenAI service. Let's make this a little bigger. OpenAI service is being returned here. Okay, cool. So this means inside our service provider, we have now defined for the image generator and for the blog post generator to use different dependencies when asking for an AI service, which when you read this is just so cool what it does, and it's so clear what's happening here. And this is a very powerful concept of the container as well. I just love it. But again, there is more. So another topic that I want to talk about is testing and the service container. So let's create a new test. Feature test, let's call it generate image test. It generates an image. All right. So what we do want to do, we need an image generator. Let's create one. Again, very simple image generator. It needs an AI service. Let's use OpenAI, which needs a client, and it needs an API key. Let's go for 1, 2, 3, 4 in this example. All right, then we're going to generate an image. Generate a cat. All right, and then we want to assert, we want to expect that what we get back, our image, in our case, it is a string for this test here, for this test example. We want this to be, I think it's generated image for a cat. I think so. Let's check out. Yeah, that worked. Just to be sure, if we change this to dog, it should fail, and it does. All right, so we have successfully written a test here for our image generator. But what's also happening here is that we're using our OpenAI service, and I'm pretty sure we would make a call to this AI service, which is maybe something that you don't want to do inside your test because, yeah, this is a heavy operation. It maybe costs you something. That's something that you don't want to do. So what can we do about this? There are a few options that we have here. First, if you are using the HTTP client in Laravel to make those HTTP calls, you can just fake those calls. And let's say everything to OpenAI, that's something you want to fake, and you want to return a specific response, some specific data, some JSON that you can define here. So this works, but then you have to use the HTTP client in order to make those calls in your classes as well. So this is a cool thing. We are faking the client that we're going to use to make these calls. That's something that you can do. I'm also using this in various of my projects. I really like this, but we want to talk about something else. We want to talk about using different dependencies, fake dependencies. So the idea is, since we have now defined which services we're using, AI service, the client, we can also change this here when we create our image generator. And in this test here, we want to make sure that our image generation class works, and we're not so much interested that the AI service works. And we can just replace our AI dependency with a fake one, fake AI service, which doesn't need any more dependencies, no client, and no credentials. Let's run this test. You can see this is still passing, and now let's take a look at this fake AI service. It also implements our interface, which is very important. And the rest looks very much similar. We're just returning a string here. But the point is, with those fake AI services, you can make sure that you don't make an HTTP call. You can store what's being received. You can add some custom assertions on it. And it's very nice to use. And in this case, it's just important for us that we don't make any HTTP calls for this test. Okay, so this test is already passing, but we can do a little bit more here. First, again, we also don't want to create all those here together. We could also use the service container, and we can use one of the methods to talk to the service container, and one is resolve, which just means you want the service container to resolve a specific instance for us, and in specific dependencies. In our case, it's the image generator class here. I already did also a video about all the different ways to interact with the service container in order to get something out of it. So yeah, check this out as well. The link is up here. Let's run this again. This is still working. But the issue now is, if we take a look at the AI service here, you will see that this is now not our fake one anymore. Let's run the test again. And you can see that we're using Cloud AI service here. So we want the service container to give us the dependency that we're here, but we still want to make sure that we use a fake one. So what can we do here? We can do something similar, which we have already done inside our app service provider. Let's copy this, bring this in here. So we're doing exactly what we did in the service provider now inside the test. And when the image generator needs an AI service, we're going to return, here in our case now, a new fake AI service like this. Let's run this. And now you can see we dump out the fake AI service because now we've successfully switched it out. Let's get rid of the dump here again. And now we're using our fake AI service, which is pretty cool. I think it would also be cool if we clean this up a little bit. So since we're doing this here, we can also do this inside our fake AI service with a fake method. We don't have this yet. Let's create this and let's bring this in here. And now here we're using app helper to get access to the container, and we are done returning anything. So with a little bit of luck, this should still work, and it does. And just to be sure, let's dump out the AI service again so that we see which one we are using, and it still should be the fake one, and it does. Perfect. All right, this is pretty cool, and this might look a little bit familiar to you because we have these fake methods on Laravel facades as well, like the mail one, or also on the HTTP one, which I already showed you, or we also have this on the queue. Yeah, those fake methods you probably know, but now they are used on facades. So think about what it would be like if we had a facade for our AI service. So I think it's a good idea to just create one. So let's add a new directory called facades. And now let's create a new class called AI. So we want an AI facade, and what makes a facade, a class, a facade is the facade class that we extend, and we need a get facade accessor method. So what this does, it returns a string which is the key of the service that we want to use under the hood. In our case, it's the AI service interface that we want to use. So this means whenever we use our AI facade, under the hood, we want to use what is bind to this key in the service container, which would be one of our AI classes. All right, let's take a look at this is already working. Let's dump out if we want to use our facade. I have already auto completion here through Laravel IDEA. And let's just generate text, test here, and we should see an output, which we don't have yet. Let's check what this is about. Oh yeah, inside our app service provider. Let's go back here. Let's change this back to binding to our interface. And then let's get rid of this again. So we're back to the state where we're binding to the AI interface, one of our AI services. And then back here, we should get something back now, and we do. So our facade is already working. As you can see, it's pretty easy to set up a facade. And it's also interesting. Let's keep this here. We also have this method here, getFacadeRoot, which is also nice because this tells you exactly which service you're using under the hood with this facade. And in this case, it's the Cloud AI service, which we have defined here in the service provider. So getFacadeRoot, a method to remember for sure. Okay, I like this. What we now could also do is, let's try this out inside our image generator. We could get rid here of dependency injection and directly use our facade now. Let's take a look. Our test should still pass, and it does. And now this is a little bit different. We are still inside the method where we use our dependency, so we don't see at the beginning of the class what dependency we're using. We're not injecting it, but we are still using the service container, so we still have access to override it, which is way different from when we would just new up an AI service like this. So yeah, there are a lot of advantages from using a facade. The only disadvantage that I would say is that you might tend to use them more than you should inside one class. And with dependency injection, it's just more clear which dependency you use. That's the only little downside for facades, I would say. But yeah, besides that, I really like using facades. So let's keep this here. And in our test here, now it would be really cool if we could use our AI with a fake method, similar to what Laravel does with a lot of its own facades. And yeah, we can do this as well. So what does this fake method do? We're not going to return anything. And we're using a method that comes with facade, which is called swap. And with the swap method, we can just swap the real implementation with something else. In our case, our fake service. So if we now try to get, let's try again to get the facade root. And this should be now our fake service. It does. And if I comment this out, it should be Claude again. Yeah, like you can see here. So let's bring this back in, let's clean this up, and now you can see how cool this looks. Directly at the beginning of our test, we're faking up our AI service. And for this test now, we're using the faked service, but still inside our application, we can use the facade directly if we want to use the specific service that we have bound to the service container. And again, when you take a look at example, what the mail fake method does, this is very similar to what we have done, where we're also swapping out with the fake one. So again, check out what Laravel does itself. And yeah, we got a little bit inspired here for our example for our AI facade and fake method. Yeah, and this is one of the reasons why I love facade for testing. Facades are really good for testing, but in general, the container helps you a lot while testing. We want to swap out specific implementation, specific dependencies with the one that you don't want to use for a test. So like here example, where we want to concentrate on our image generator. So the service container can help you a lot while testing. Another thing that we need to talk a little bit about, that currently we have only binded like normal classes, but you can also bind singletons, which looks like this. Under the hood, it's just the same as using the bind method, which has a third argument called shared, which is currently false. If you use a singleton, this will be true, which just means that the same instance that we create here the first time will be shared with the next calls where someone else in your code needs this dependency. So the same instance will be returned within one request. If there comes another request in, it will always be a new one, but within one request, it will be the same instance. And there are two main reasons where singletons make sense. The first one is where creating this instance, this dependency, might be a little bit heavy or complex or takes a little bit more time. Then you don't want to do this like every time. So then you just store it the first time. The second reason why it makes sense is when you want to keep the state of the instance. So for example, you change the state of your instance, you store something inside the class, the instance, and then you want to use the same state of the instance again the next time someone needs this service. And if you take a look at search for singleton inside the Laravel code, you will see there are a lot of singletons used here. So yeah, if you want to learn more when this makes sense, take a look at the examples that Laravel uses itself, which is pretty cool inside the framework. Whew, all right, this was already a lot. Let's get back to where we started. So we talked a lot about dependencies, when it makes sense to use constructor injection, when it makes sense to use auto-resolving like we did in our controllers here, like here through method injection, but it also works through the constructor. And then we talked also when auto-resolving does not make sense anymore, when you have dependencies like a string or an array where Laravel does not know how to create this. And then you need to go to a service provider, the app one or a new one. Then you have to directly specifically tell the container how to create a new instance of a dependency, where you now have this one place to define this. And if you take a look, every package has a service provider, every package brings some services to your code. So if you take a look now at the service provider of the next package that you install, yeah, you will find similar things, and it's always interesting to see how they bind to the container. And yeah, it's a good example where you can see facades and service providers and the whole container in action in real world examples. Okay, wow, that was a lot, but I really hope this practical approach helped you to better understand the parts of the container that you still struggled with. We also touched a bit more real-world examples and more advanced features, but of course there is much more to learn about the service container, so please check out the official docs as well. I hope we gained some more container fans today and you will start using some of the cool features that I showed you today. I wish you a lot of fun, and please tell me if you liked the video, and actually liking it as well is great too, or give us a subscribe, which we will be very thankful as well. So see you next time. Bye.